got the 2200 grit sandpaper out. Kaz is in the building. 2, 3.
Hey guys, welcome to the final Comsci 1MD3 tutorial. and today we're going to be covering SQL. So it's going to be databases and everything to do with databasing in Python, and also a little bit of stuff about how to use SQLite 3, which is the Python module that lets you integrate SQL into your Python code. And it's something that will likely come up in the exam, so it's definitely good to know. And afterwards, if there's any time left, we can always cover any questions you guys might have regarding anything else, including like assignments or questions about tests, etc. So let me start sharing my screen. So hopefully people can see that. Okay. So basically the plan today, until we finish, is to cover some SQL basics. So we're going to teach you guys SQL, assuming you guys have also learned a little bit in the lecture, hopefully. So these basics are going to cover pretty much anything that you can be expected to know on the exam, which is great. So we can start off right here. This is a really good resource as well, which I'm going to share to you guys right now in the chat. So if you go there, you can find what we're working on here. And basically the way SQL works is SQL holds databases. And databases are composed of what we call tables. And what you see here is an example of a table. So this table is called world. Each table has a name. This one's called world. And just like you'd think, a table has rows and columns. And basically each row is an entry in the database. So for example, in this world table, we're storing countries, and along with those countries, we're storing which continent they belong to, their area in square kilometers, I assume, their population, and their GDP. So each one of these rows is a different entry in the table that we call world. So when you have this database that is already composed of a bunch of different entries, very frequently in databasing, you're going to want to select or constrain your table to only match a certain number of entries, and you do that using SQL queries. Now, what SQL queries do is they basically go through the table and they use some sort of constraints that you give it to only return a subset of the data in the table. And that's very useful because sometimes you want to, for example, find every country in this table that starts with the letter A, whose name starts with the letter A. Or you might want to find every country that belongs in Europe. Or you might want to find every country that has an area less than 1,000 square kilometers, right? And so on and so forth. So that's what queries are for. And we can take a look here. This is what a basic select query looks like in SQL. You see that here, all of the keywords are capitalized. That's just like a practice, like a good practice. That's kind of the standard. So here we're saying select, and then after select, you say what you want to display, and typically it's a column. It's either a column name or it's something to do with column names. So here we want to select the population column from the world table, and then there's a where clause here. And this is basically like a conditional, just like an if statement in Python, where you are constraining the data. So you're saying, show me the population column and table, but don't show it to me for every single entry. Only show it to me for entries where the name of that entry is France. So it's going to look at each entry, it's going to look at the name column, and if the name is France, then it will show you the population column. That's kind of what this is doing. And you see here that if we submit that, our answer is this. But this is the population of France because that's what we specified. So here the question says modify it to show the population of Germany. So obviously that's very easy. If it currently shows the population of France, all we got to do is change this to Germany. Let me actually zoom in because I'm guessing this is pretty small for you guys. And if we submit this, we get the smiley, we get the correct answer message, and this is the population of Germany. For anybody who's just joining, I sent the link of this in the chat, so you're free to follow along yourself, or you can just watch the tutorial and watch me go through it. And obviously feel free to ask any questions along the way if you have any. So here we have some more. Checking a list. The word in, which is another SQL keyword, allows us to check if an item is in a list, just like the Python keyword in. So that's very handy because we already kind of know it. The example shows the name and population for the countries Brazil, Russia, India, and China. And we just got to change it by changing the countries. So here, if we submit this currently, you'll see that it shows us the name and population columns from our world table where the value of name is in this tuple, right? Just like it would work in Python. So here all we got to do is just change this tuple. Instead of Brazil, Russia, India, and China, we can just change it to Sweden, like that, Norway, and Denmark. And we can cut off all of the rest. And now if we submit this, we got the correct answer. So it's pretty elementary stuff so far. I'm sure no one's having too many issues keeping up. So I think we can move on. So just to quickly recap, we know what a basic select statement looks like. We know how to constrain it with a where keyword. And we also know how to constrain it further with the in keyword. So one more question here. We have, which countries are not too small and not too big? And this introduces the between keyword in SQL, which basically lets us see if a value is in between two values. And the way you do that in Python is you just say, if area is greater than 250,000 and area is less than 300,000. But this between keyword basically accomplishes the same thing as doing that. And you see here that it says range specified is inclusive of boundary values, which means that it will include any countries where their area is actually 250,000 or their area is 300,000. So it's inclusive. Here we just have to modify it to show the country and area for countries with an area between 200,000 and 250,000. So you can already see the structure of the statement. All we got to do is just change these values very simply like that. Cool. So that's the end of this SQL basics tutorial. Teaches you the bare bones basics about SQL select queries. And so now we can do a little bit more because you might have to know a little bit more for the exam. So let's move on to, if you go to this left tab, right below the basics quiz that we just did, we have the world quiz. So let's take a look at that. It says in this tutorial, you will use the select command on the table world. And this is basically the same table that we were just working with. So we kind of already know what it has. And obviously this tutorial is a lot bigger. There's a lot more stuff. So I'm going to cover some of it, but not all of it. And then we're going to jump into SQLite 3, which is how we're going to integrate SQL into Python, which is what you're going to actually need to know for your exam. But you're also obviously going to need to know how to use the SQL in the first place, or else knowing SQLite 3 would be useless. So we're going to keep on going with a little bit of this. It says, read the notes about the table. Observe the result of running this SQL command to show the name, continent, and population of all countries. So that's easy. It's just saying that we should understand how the table is set up. Clearly, we see an example of a subset of the table. It's got name, continent, area, population, GDP, and here we're showing 3 of those columns for every country. And it's just cut off because it would be too big. So we got large countries. How to use where to filter records. Show the name for the countries that have a population of at least 200 million. 200 million, and they're just saying it has 8 zeros. So we have select name from world, where population is greater than whatever this is. That looks like 1 billion. So we just got to change that to 200 million. And that's right. Let me just check here. Okay, yep. And per capita GDP is the next one. give the name and the per capita GDP for those countries with a population of at least 200 million. Now, this one's actually a little bit interesting because it might not be as straightforward as you think it is. So actually here we finally don't get like a preset one. We actually have to do it ourselves. So this would look something like this, right? We're saying select name GDP from world, our table, where population is at least 200 million. 1, 2, 3, 1, 2, 3. So we get a wrong answer. And I did this on purpose. I want you guys to see if you can spot what's wrong. And just to save time, the issue here is that they asked for per capita GDP. And we're just returning GDP. So if you guys know what per capita GDP, the hint is in the name. Per capita means per person, per capita in the country. So all we got to do is modify this column so that instead of showing GDP, it shows per capita GDP, which is as simple as dividing that GDP by the population. And just like that, our answer is now correct with the smiley and everything. And here's what that table looks like. Yep, Juhu got the correct answer in the chat. So hopefully nothing's too tricky here yet. We got some more. So here we got to show the name and population in millions for the countries of the continent South America. Divide the population by 1 million. Or yeah, 1 million to get the population in millions. Yep, which makes sense. So all we got to do is select the name and population from our table world, where continent. And the thing with this one is we can actually just use equality, just like you'd probably guess. So South America, and we got to show the population in millions. So all we got to do is divide that by 1 million, just like they told us to. And easily, we get the correct answer. And this is what it looks like. So Argentina's got 42 million people, population, so on and so forth. And this country only has 100,000. All right, show us the name and population for France, Germany, and Italy. So we've done something just like this in the basics. And hopefully you guys still remember. We basically want to see if a country is either France, Germany, or Italy. Now, we could say if name equal France, or name equal Germany, or name equal Italy. But as you know from using Python for this long, there's a much better solution to that, and that's using the in keyword. So here we're going to select name and population from our world table, where the name is in France, Germany, Italy. And we get the correct answer. Now you might have noticed that some of these statements have semicolons at the end of them. That is the correct way to do it, but depending on which SQL language you use, sometimes it's not required. And also some interpreters like this website don't require them. But just for safety, you should end each query with a semicolon just like that. So here we are, we're keeping on going strong. Shouldn't be anything that stumps you guys so far. Show the countries which have a name that includes the word united. Now this is where things get a little bit fun. Here, I don't think any of you guys can think of any keyword that we've encountered so far that lets us do this. How? Because so far, what we might do is something like this. Select name from world, where name And then what do? It's kind of tricky because you can't equate it to anything because we don't know exactly what we want to match. We just want to match anything that includes the word united. So this is where we can use a special keyword called like. And like allows you to do something called pattern matching. Basically allows you to match a value, in this case it's the name, to a predefined literal. And this is what it might look like. So you give it a string, and the way it works is that we have special characters that we can use, and they're called wildcard characters. For example, a % means anything. So anything can go before united, and it doesn't have to be just one character. It can be a string of characters, it can be no characters, it can be anything at all. So, for example, in the case of the United Kingdom, this % would be nothing, and this % would be space kingdom. And since they're wildcard characters that can represent absolutely anything, including nothing, this would work to show any countries that have a name that include the word united. And we get the correct answer, and you see that what our query actually returned, and we can throw the semicolon in there, is the names of countries that include united, such as the United Arab Emirates, United Kingdom, and the United States of America. Cool, so that's an important one. Know how to use like. Not too sure if we're going to ask you about it, but it's definitely good to know. Basically anything on this page, selects from world, if you know everything here, you are more than fine, because we're probably not going to even go this complicated. So we'll do a couple more, I think. I'll quickly scan, see if there's anything. Yeah, this one would be good to do. Actually, this one's good to do too. So, not too bad though. This one just teaches us how to use conditional. So the question says, a country is big if it has an area of more than 3 million, or if it has a population of more than 250 million. So now we have to use logical operators, like or. So we're going to say, select name, because they want to show the countries. Actually, it says show name, population, and area. So name, population, area from world. This is always the format we use. Where, this is the cool part, we just say area is greater than 3 million, or population is greater than 250. Is that enough zeros? Yeah, 250 million. And we get the correct answer. So that's how you use the or operator. One or the other, but not both. They want us to use exclusive or, which is exactly what this says. It's just one or the other, but not both. That's not really important, so I'm not going to go over that. That's just a different type of operator that should not be important. This one, however, is important. Now this is to do with rounding. And here they want us to show the name and population in millions and the GDP in billions for the countries of South America. And they want us to use the round keyword for that. And now that's actually really easy because the round keyword in SQL happens to work the exact same way as the round keyword in Python. So I can show you what that looks like. We have to show the name in millions, so we divide by millions, and the population, population in millions as well, and the GDP in billions. That's 9 zeros. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. From world, where continent equals South America. And you got to be careful because it's case sensitive. So if a table entry has South America spelled like this with these capitals, it is case sensitive, so you have to match it exactly. And now this is pretty much what we want to do, except we have to round it to 2 decimal places. We have to round the values that we just divided, right? Name, population, GDP. So works exactly the way you think, just like Python. The round takes 2 arguments. It's just what you want to round and how many decimal places you want to round it to. So we just do this. Nothing too confusing. And we submit that. Oh, and we have an error. Oh, oops. I don't know why I tried dividing name by 1,000,000. That doesn't make any sense. Or try to round it. It's a name, not a number. So let me just select name. That should make more sense. Yeah. Let me get the correct answer. I'm gonna see if there's any more good questions that we should do. And if not, we can just go right to SQLite 3, because we're actually covering this stuff pretty fast, which is good. Okay, let's try this one out. Show the name and the per capita GDP. We know how to do that. For those countries with a GDP of at least 1 trillion, that is 12 zeros. Round this value to the nearest 1,000. So that's actually pretty cool. When they say round this value, yeah, they're talking about the per capita GDP that we're displaying. So what we're going to do is we're going to select name and GDP divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 12 zeros, that's 1 trillion. And let's just fill this out from world where GDP is at least 1 trillion. So GDP is greater than, just copy this number. And we want to round this GDP this per capita GDP to the nearest 1,000. So we shouldn't be dividing by a trillion here. That was a mistake. We should be dividing by the population because it's per capita. And then if you want to round to decimals, you would say 2, right? Because you're basically truncating the decimal place from where it is to 2. But if you want to show it to the nearest 1,000, what you'd actually be doing is, if you think about it, you're moving the decimal place backwards. You're moving it further into the number. And when you move it further into the number, the argument that you're going to provide to round is actually going to be negative. So we're going to be saying -3. And that's correct. And you can see that all of our answers here are rounded to the nearest 1,000. Because if we just rounded it to 1, for example, you see that we get 1 decimal place. If we round it to 2, we get 2 decimal places. If we round it to 0, we get no decimal places. And if we round it to -1, we get it to the nearest 10, right? And then you keep going. Nearest 100 would be -2. Nearest 1,000 would be -3. And hopefully that makes a lot of sense. So I feel like this stuff is getting a little bit, yeah, I think what I've shown you is more than enough of what you're going to need to know. If you want to, you can feel free to practice 11 onwards on your own, and if you have any questions, you can feel free to ask me about them. But it's just 3 more, and they're a little bit more advanced than anything you're going to need to know for this exam or this course. So with that being said, we can move on to showing you SQLite. So I have a pretty cool, so the plan here was to go over the SQL exercises, which we just did, preview the video games database in Online DB Viewer, and work with that database using Python. So the database here, I'm going to show it to you. Here's my working directory. Here's this notebook that I just showed you. And here is the database file. The database file ends with the extension db, and it basically contains tables, just like the tables that we've just been working with in the tutorial. So there are some online database viewers, which let you open these databases and view their tables online. So I found one here, and I'm going to also throw this into the chat, just in case you guys want to check it out. But if you just search, if you were to just search database viewer online, you'd find this stuff. So I'm going to drag our videogames.db file in here, just like this. I'm going to drop it in, and you can see that it instantly loads up. And here, this drop-down menu shows you all the tables that we have access to. In this case, this database file only has one table, and it's this table called Mario Games. So the previous table that we were working with was called World. This one's called Mario Games, and you can see that it says it has 11 rows. Let me zoom in a little bit here. And those 11 rows are shown right here. And you can see that here are the column names. We have game ID, which just is a unique identifier for each of these rows, just numbered 1 through 11. The game, which is the name of the game. The dimensions, which is what kind of game it is, right? Is it a 2D game? Is it a 1D game? Is it a 3D game? And then we have a final rating, which is a real number or a double. And that's the rating probably given by some game critic, right? So what we can actually do is, now that you guys know what this database looks like, roughly, we can start working with the database using SQLite, which is a Python module. And it's called SQLite 3. I'm going to zoom in here. That's what it looks like. And it's got a little bit of a learning curve. So I'll show you guys some of the basics. And I'm going to reiterate something right now. So on your exam, you might be expected to write your own query, right? But we will give you all of the SQLite 3 code you need to do that. So let me demonstrate. Let me first write the SQLite 3 code, and I'll show you which part of that code you might be asked to change or to modify in the actual exam. First, we have to actually instantiate the connection to the database. So we could do that by using the modules connect function. And all we got to pass in here is the name of the database file that we're trying to connect to. Here it's videogames.db. Oh, we have a question. What does that star mean? Yeah, that's a great question. I think that came from right here. So previously what we've been doing is we've been saying select name, population, GDP, where we're specifying which columns we want to actually display. But when we use the asterisk means everything. So here, it would select every single column from Mario Games. So basically, that's another wildcard that you can use. But this is for columns. So actually, if you execute this, this command is what gives us this result. So yeah. If you've used Bash, the scripting language like Unix, shell scripting, it's very similar to that wildcard asterisk. So let's keep going. Once we've established our connection in the DB, we need to establish something called a cursor. And we do that by calling the cursor command of that connection that we've established using the database. It's a little confusing, but once again, don't worry because all this code will be given to you. I will tell you exactly which code is not going to be given to you. So now, let's see what happens if we execute a command. So using SQLite 3, the best part about this module and the whole point of it is you can actually execute SQL queries through it. So we can do something like this. We can say cursor, this cursor that we just defined, dot execute, and then we pass in an actual SQL query as a string. So let's use that asterisk wildcard, which I just talked about. We can say select everything from, and then let's go back to our viewer and see what the name of the table was. It was just Mario Games. You can copy that. From Mario Games. And yeah, let's just return that. Okay, so it returns a cursor object. So not exactly what we want to do. Let's try printing this and see what happens if we print the result. Okay, no different. So even though it is returning an object, this object is actually iterable, which means that you can iterate over it. So let's store this. Let's store this in, what just happened? Sorry. In a variable called result, right? And now, since I just told you that the result is iterable, we can actually iterate over the result. We can say for I in result, or actually, you know what, just to clarify, I'll say for row in result, because that's basically what we're doing. We can print that row. And boom, you can see right here that everything worked. So each entry in our query was provided to us in the form of a tuple. You can see that each tuple here has the game ID, the game, the dimension, and the rating. And we can do whatever you want here. So it's really cool. We can we just have to remember to actually close. Let me just do something real quick. You have to close it each time, or else we might as well get some troubles. Yeah. So that works fine. And that's pretty much the main idea. So what I wanted to show you guys is that what you might be asked on your exam is to modify this part, right? We might ask you to find a way to select a certain subset of entries. Or we might ask you to insert a new entry into the database, which I'm going to show you how to do, or to update a new entry in a database. So let me leave that there. Or actually, let me go back and just comment this out real quick and run that. And let's actually copy this over. And we'll say db close down here again. And then we can get rid of this. Okay. And we'll copy this over. Cool. So here, so actually let's title this. This was the select example. Now I'm going to show you guys how to insert, which is another cool thing that we can do. So this is the insert example. So we have to establish the same connection. We got to make the same cursor. And this time, instead of storing the answer in a result, what we're actually going to be doing is inserting something. So the way you do that is like this. And I'm going to show you how to do that. Basically, the format is insert into, and then you say which table you want to insert. So insert into Mario Games. And then you say values, and values is another keyword. And then once you said values, you specify which values you actually want to insert. So that would be in the form of a tuple. You specify the actual row or the entry that you want to insert into the thing. So you know that right now, the table looks like this, right? We have 1 through 11. So let's insert a new row, and let's give it an ID of 12, so that it sits just at the bottom here. So the values, we would specify them in the same order as they're displayed in. So first the ID, then the game name, then the dimension, then the rating. So we could say something like this. We could say 12, right? And then Basil Mario, for example. And let's say it's a 4D game for fun, and we'll give it a rating of 110.1. Or actually, let's just do 99.9. Cool. And once we've done that, we have to actually commit the change. But once again, don't worry about that. Because all this stuff is going to be done for you. Once again, the only thing we might expect you guys to do in the exam is to modify the queries that we're actually doing here. So we might say, like, replace this query with a query that does this. For example, with a query that selects these things. Or we might say, write a query that inserts this stuff into the table, et cetera, right? But we're not going to expect you to know how to commit, how to close, how to establish all these connections or this cursor. All that stuff will be given to you, pre-given in the question. So now, if we actually go back here and we select the stuff again, right? Let's select everything and print it again as well. Let's see what happens here. So we get an operational error, which is a little bit unfortunate. So let's see what's going on over here. Don't think this is going to do anything, but yeah. Videogames.db, we're connecting, we're establishing the cursor. Yeah, all of these errors, by the way, all these errors that we're getting are just to do with the actual oh, could it be, this should be enclosed in string quotations. Okay, so that was the actual problem, but now we're getting a different error talking about the database is locked. And this is a very common issue I've had to deal with that I haven't really understood how to fix. This is just an issue with SQLite 3. It's nothing you guys have to worry about because our statement here is fine. It's just the way we're committing here that's a little bit questionable. Yeah, we're gonna get the same error. Okay. Clearly, I can't commit. I'm not allowed to commit for some reason, so I just commented it out and it worked. You can see basically here what happens. After we execute the cursor command and you know, execute this second selection command, right? First we insert, then we select, and then we print what that selection returned. And you can see here that it's been updated correctly, just like we wanted it to. Now, the only thing that db.commit does is it actually commits those, it commits this query into the actual file. So if I was allowed to run db.commit, it would actually go in here and modify the database file accordingly. So since I commented that out, it actually didn't it actually didn't modify videogames.db at all. It didn't actually change that. It just changed it for us locally here, but it didn't actually put those changes in. But don't worry, once again, that has nothing to do with what you're going to be tested on. All you're going to be tested on is the actual queries that you write. Cool. So that's insertion. Let's go down here and copy that over. And now we're going to do updating, which I'm sure you guys can probably figure out what update's going to do. We've done selection. which views stuff that already exists. Insertion, which adds entries into tables. Update simply updates entries that already exist in tables. So now that we have this, we can update it to something else, right? Now, if we just do this here, you'll see that our change from earlier didn't carry through because we weren't able to commit it. See, like we're establishing that connection from up here. Now, what we can do is we can actually just, if we run this, and then just comment this stuff out. Okay, and we don't close it. Oops. So let's run this again. Let's run that again. Oh, okay, and we're actually able to work with our previous stuff. Even though it hasn't modified the file, since we're basically just carrying on from the previous cell. So let's work on updating. So updating is pretty simple. Basically, the format it is we're going to use a keyword called the set keyword. And just like with insert, there is a keyword into, where we say insert into table. Here, what we do is we say update table, set, and then we start setting variables accordingly. And so here's how we could do that. Let's copy this one over, put that right here. So we could say something like this. We could say update Mario games, and set, and then we're going to set all of our variables accordingly. So we're going to say, let's say we wanted to update Basil Mario from dimension 4 down to dimension 2. Let's say we wanted to make it a 2D game instead, right? So we can say set dimension equal to 2. But if we just ran this, we're not specifying which row to update. So we have to actually specify, just like we were specifying in the SQL queries earlier, where we have to find some way to specify this one. So we could say where game ID equals 12. And hopefully that should work. Was the game ID actually, yeah, it was actually spelled just like that. Remember that we have to actually match the cases exactly. So game ID is, let's try running this. Oh, sorry, actually, instead of doing this, let's do exactly what we did over here. And so after we update them, we're going to select them and display them. And hopefully that works. So once again, we closed it. Now, why did we close it? Could have sworn that we were fine. Okay, so now the database isn't closed anymore. We fixed that. I don't even know why I was bugging out in the first place, but dimension does not exist. So we said set dimension equal to 2. I thought, oh, see, it's called dimensions. So I accidentally mistyped there. Let's just go back here and say dimensions. And let's try running that one more time. And boom, we have a correctly updated table. You can see the last column here now says 2. Let's save and checkpoint this. So we went from 4 to 2, which is all great. Yeah, let's run this. Okay. Database is locked. Oh, I didn't mean to run that one. Let's run this one. Sorry, I just want to have everything displayed so that everyone can see that. Cool. So we go from here, which is the original database. Here we're just selecting them and displaying them, to this one where we insert this brand new row right here at the bottom, game ID 12, Basil Mario, dimension 4, and down to this one where we update, we change it from 4D to changing row 12 from 4D to 2D. And then finally, the last one you guys need to know, which is going to go perfectly with what we're about to do, is our delete example. And here we're going to delete row 5, for example, right? We can do anything we want. So the format for deleting stuff is very simple. It's basically the same as select, right? Except now instead of showing something, you're deleting it, which is very risky. So be careful what you do, right? Who can guess what something like this would do? If we executed this command, can anybody guess, based on what you know so far, what that line of SQL would do if we ran it? Okay. Don't know if anybody's going to put in the chat, but it just deletes, yeah. Okay, so Ju got it. It's going to delete every single row. So here it's going to delete every single entry from Mario games, which is not good. So be careful when you're doing stuff like that. So instead of saying delete all, we can say delete from Mario games where, and then we can specify anything that constrains it, right? So we have to be careful because let's say we said something like this, right? Oops, what am I doing? Where dimensions equals 2. If we did something like this, it would delete every single entry from this table that has dimensions as 2, right? And so if we want to delete a specific one, we have to use a constraint that's actually unique. So can you notice anything that is guaranteed to be unique? Obviously, it happens to be that each of these names is unique, but I don't know, who knows? There might be somehow 2 games that have the same name for some reason, who knows? But basically, you know that this game ID was built for the whole purpose of being unique. So if you wanted to, we could refer to row 5 just by its game ID. We could say where game ID equals 5. And then after we run this command, if we were to select everything, every row, and display it, excuse me, you'll notice here that we successfully deleted row 5 because that was the only row that had a game ID of 5. Let's comment this out and display again so that it's already gone. Let us try this, where dimensions, so what's left here? We have some 2D games, some 1D games, some 3D games. Let's try deleting everything that has dimensions equal to 2. So no 2D games anymore. We'll run that, and boom, our list shrinks even more. Now we only have 1D, 3D, 3D, 4D games. All of our 2D games are gone. So that is everything that I've had to show to you today, and that's more than enough of what you're going to need. So I'm going to insert even a note up here, and I'm going to say note. the only thing we might ask you to do on the exam is to modify, write your own SQL queries, aka changing the string that goes inside the cur.execute calls. And what would happen here, right, is like all the stuff would be given to you. The only thing you'd have to do is change this string. And actually, well, what might happen is we might make it so that all you have to do is define a function that just returns the correct SQL query string respective to the question, right? So for example, it might be something like this. Right? And who knows, you might have to code a line just like this. Right? And then our hidden test cases would take care of everything else. Our hidden test cases would actually build a database, it would establish the connection, it would build the cursor, it would execute your command correctly, it would execute the command that you return, and then it would compare the results to some predefined test cases that we're going to write to make sure that your command was correct, right? So that's what I'm trying to tell you guys is don't worry about any of the stuff to do with SQLite 3. All you got to know how to do is correctly write these queries accordingly. So know how to use select, know how to use insert, know how to use update, and know how to use delete. Because who knows, any of those things might be tested. So I saved that, and I'm going to upload it to Avenue, just in case you guys want to look back on it later. And does anybody have any questions about any of the stuff we've done today? Because otherwise, this was the last tutorial. I can take up any things from assignments if you guys want. But that's it for official CompSci 1MD3 tutorial time. So it's been a fun ride so far. Yeah, no problem. Anytime. If you guys have any questions about assignments or exam prep, feel free to send messages on Teams. Yeah, you can just add me on Teams and I can reply over there. Yeah, no problem, Ju, no problem, Ivan. Best of luck on your exams, guys. And yeah, feel free to reach out if you need any help. All right.